Okay, P is this, Q is this, the matrix PQ. Okay, now this is multiplication. Okay, the addition subtraction is very straightforward. Okay, only the multiplication that students always have issue. So PQ, 1, 2, 3, 4, minus 1, 0, and then after that 3 minus 1, 1, 0, 1, and 2. Okay, what I want you to do is you need to know whether the multiplication is a valid multiplication or not. So you need to find out what is the order of the matrix. So you need to remember this thing called RC, row and column. Okay, RC. So how many rows is this? This is 2 rows. So this is 2. How many columns is this? You have 3. So it's a 2 by 3 matrix. Okay, now let's take a look. This one. There are 3 rows. Okay, 3 rows, and then there are 2 columns. So this is a 3 by 2. So how to know whether is it a valid multiplication? You have to make sure that the inner 2 numbers is the same. Then you are allowed to multiply. Okay, I want you all to write it out, this thing. So then after that, you look at the so-called remaining number 2 and 2, right? So you know that eventually you will get a final matrix, which is a 2 by 2. Okay. Don't underestimate writing this out. Why? Because sometimes the question as you do behind kind of problem sums, you know that you want to use this matrix multiplied by this matrix, but sometimes you don't know whether do you want to put it in this combination or do you want to put it in the other combination. So by writing out the matrix order, you will know that, oh, which one to put at the left-hand side, which one to put on the right-hand side. And after you put at the correct order, whereby it's a valid multiplication, then finding out the ending order of the multiplication, okay, it will also tell you that after you do your multiplication, your final matrix, what should you get? If you know that, oh, it's a 2 by 2, so that means I know my ending must be a 2 by 2. If you don't get 2 by 2, that means somewhere is wrong with your multiplication. Okay, so let's proceed. So the first, what I do is, I will always say, okay, so I will always say that, okay, first row multiply by the first column. Okay, first row multiply by the first column. I always do this. Then what you do is 1 times 3, 1 times 3, and don't use the multiply. I always use bracket. So 1 times 3 plus 3 times minus 1. So 3 times minus 1 plus minus 1 times 1. Okay. Then after that, you leave a gap. Go to the other side. So it will be just now was first row, first column. So now the other side will be first row, second column. So it means that it will be first row and second column. So you go to the leave a space, then you say, oh, 1 times 0. So same thing, 1, 0, 3 and 1. So plus 3 and 1. And plus negative 1 and 2. Okay. Now is the second row and the first column. So it's a bit like, rainbow, but it's just that it's in matrix numbers multiplication. So now is 2 times 3. So I put 2 and 3 plus 4 and negative 1. Okay. And 0 and 1. 0 and 1. Okay. And then again a gap. So now is second row and second column. So 2, 0. So it will be 2, 0 plus 4, 1 plus 0, 2. Okay, of course, don't forget to put the main thing. So of course, eventually you will get a minus 1, 2, 1, and 4. And then as to state the order of the matrix. So we know that this is a 2 by 2 matrix. Okay, so that's for question 2. So this is how you multiply. Okay, first you need to check whether is it a valid multiplication by writing out the order and finding out what is the ending order. Next is, I always draw out the first square. You don't have to draw for all of them. For me, I always draw the first row and first column, and that already guide me already. You understand? Okay, so make it systematic. This is for just question 2. Okay, question 3. They say evaluate the matrix, blah, blah, blah. So same thing. Okay, write out first. 1, 3, 2, oops. Okay, then 4, 5, minus 1. So this is how many rows? 3 rows. So this is a 3 by 1. This is 1 row, so it's a 1 by 3. So these two number is the correct same. That means it's a valid multiplication. Then you see this is a 3 by 3. So you know the ending will be a 3 by 3 matrix. You understand? So you expect to see 3 row and 3 column number. Okay. So how do you multiply? Remember, it's the first row and first column. This is a bit cute lah. Huh? This is like 1 and the 4, right? So it's like 1 times 4. Okay. Then after that, 1 times 5. Then after that, 1 times -1. The first row with first column, first row with second column, first row with third column. It's just that your first row is just one number. That's why it looks a bit weird. So then after that, it will be 1 times -1. Okay. So then after that, next is this one, 3. So it will be 3 and 4, 3 and 5, and then after that 3 and -1, and the last one 2 and 4, 2 and 5, and 2 and -1. So of course, you can see by 3 by 3, right? This will be the answer. So I'm just going to write down just 4, 12, 8, and then we have 5, 15, 10, -1, -3, and -2. So this is the answer for part A. That's for part A. They asked to evaluate the matrix product. Next, part B. They say given that P equals to this, Q equals to this, find the values of X and Y if 2P equals to Q. So sort of forming the equation, right? I'm going to write above now. 2P, so it will be 2, 2, 0, 4, 5 plus Q, equals to Q, which is 4X and Y and 10. So multiply the 2 inside, it will be 4, 0, 8, and 10. So this is like comparing, it's just comparing. So we say, okay, Y is equals to 8. Therefore, Y equals to 8. Next is X is equals to 0. So this one very straightforward, nothing much. Okay, it's still very basic. Okay, question 4. P and Q given, they say find the value of M such that MP square equals to P plus Q. Okay, so let's put M, just put that as the unknown first. P square, it means that it will be 3, 0, 5 minus 1. Take note, P square, a lot of common mistake that students do is they go and happily, I don't know what kind of, they put square, right? Then they go and square the individual number. They go in 3 square, 5 square, 0 square. You cannot do that. P square simply means that it's this matrix times this matrix again, right? So I have to write out 3, 0, 5, and minus 1. This is called MP square. Then they said this is equals to P plus Q, which is 3, 5, 0, minus 1. And my Q will be 15, 0, and 15, 3. So of course, you have to do 2 multiplication. The M, just leave it alone first, it's okay. So you see, I'm going to do it this and this. So it will be 3 times 3 plus 5 times 0. Okay, leave a space. Now it's go to the second column will be 3 and 5 plus 5 and -1. And the last second row here, it will be 0 times 3 plus -1 times 0. Then after that will be second row and second column. So it will be 0, 5 and plus -1, -1. Okay. After that, I will get M, 9 and 0. So it's 9. 0 and 0, which is 0. 15 and -5. So it's 10. 0 and 1. So it's 1. Now we have to do this side. Okay, same thing, this one and this one. Okay, matrix is a bit tedious lah. The only things you need to remember, okay, a lot of students what they do is, oh, okay, now I remember first row and first column. Then when exam come, then they will like, forget now, is it row and row or what? You understand? So always take you know, there are certain formula or certain steps whereby before you go for exam, Okay, all these things that you might know, that little things that you will forget, always write it in a notebook, a small notebook. Okay, formula also that you have to memorize. Then right before exam, right before the maths exam, the night before, take a look at the small notebook and see what are the things that you need to remind yourself. Okay, don't assume that you will remember. Have a handbook to actually refer to all these small things that is important to remember. So we're going to do the same thing. So 3 times 15 plus 5 times 0. Leave a space. 3 times 15 and 5 times 3. And let's go to the below, here and here. So it will be 0 times 15 plus -1 times 0. And 0 times 15 and -1 and 3. Okay, so let's see. This is 45 and 0, so it's 45. 0 and 0, nothing much. 45 plus 15, 60. This is 0 and -3, so it's -3. So now let's compare. So now the m, you can put it inside. It's 9m, 0, 10m, and m. And again, this is by comparing, right? So by comparing, my question is why my m is two different things. I saw something. Okay, so I make a very grave mistake. So can anybody spot out the mistake? So you see why I find out that there's a mistake. You see this 9m and 45, my m is 5. Then 10m is 60, my m is 6. I cannot have two contradicting value answer. So I spot my mistake is it's supposed to be P plus Q. It's not P multiplied by Q. So this should be plus. Okay, so it's just plus. So this is different. So this one will just be 18. 0 plus 0, 0, 20, and 2. So it will be this. Okay, 9m is equals to 18, which makes sense. My m is equals to 2. I have also another one, which is 10m. It's just to double check. It's equals to 20. My m is equals to 2. Of course, whatever m you have, it should tally. So in the end, therefore, m is equals to 2. Okay, so this is supposed to be a plus, not multiply. I make a mistake. So this is question 4. Okay, let's move on. Okay, so Mr. Vivian sells small and large tin of both blue and red. Okay, the number of tins of each type of paint, Sam, that was sold in one day are shown in the following table. I don't wish to sell paint. I'm not painful at all. Okay, are shown in the following table. Okay, the selling prices of a small tin and a large tin of either color are $5 and $12 respectively. It is given that P is equals to this one and Q is equals to this. Okay, find PQ. So this one I can just leave it to you. Okay, PQ is over here. I've did a lot of multiplication in front, so I'm not going to do it. The answer is here. So they ask you, explain the meaning of the entries in PQ. Okay, so they take 5, 8, 3, and 4. The final answer you get is 121 and 63. Okay, how do you get 121 and 63 is you did, okay, sometimes you're saying, okay, I don't know what's the meaning of it, right? But looking at the working, you'll be able to find out what is it. So you see, let me just, I'm not going to do full thing, but I just want to show you how they do the number multiplication. You see, you know that you will take 5 times 5 plus this 8 times 12, agree? Then you go and look at the numbers over here. You take 5 times 5. It means that I take the small blue 5 multiplied by $5, and then I take the 8 multiplied by the 12. and then I add them together. Isn't that the total for blue color? You understand? Sometimes you don't know what's the meaning. You look at the number that you work out in the matrix, you will understand what is it. Then let's take a look at the bottom one, which is this and this, right? So you know that you will take 3 times 5 plus 4 times 12. Then when you come back and see here, 3 times 5 plus 4 times 12. So it's actually finding the total for the rate. You get what I mean? So the meaning of the entries will be, it is the total income from the sale of the blue and the red paint respectively. Okay? You want to say it this way, or I will always say, oh, $121 will represent the total income from the sale of the blue tint. Okay? The $63 is the total income from the sale of the red paint. You also can separate and show that what is the individual number. You understand? Okay, part C. They say find 1, 1 and P. So what does 1, 1 P? Okay, if you don't know, never mind. Okay, we can just work out. See, I'm going to put the 1, 1. And what is my P? My P was this one. No, P is the top one, this one. So 5, 8. So you put here 5, 8. And 3, 4. So of course, what you have to do is you have to, this is a 1 row, 2 columns. So it's a 1 by 2. This is a 2 by 2. 2, 2, correct. So I know my ending is a 1 by 2. So let's do it. First row, first column. So it will be 1 times 5 plus 1 times 3. Okay. And then after that, first row, second column. So there will only be first run row. So that means you become 1 times 8 plus 1 times 4. So it will be 5 and 3. So it will be 8. And then this one will be 12. So analyze the thing. Okay. What they do is they take 8 and 12. So they actually add these two numbers together, right? To get two separate numbers. Then you go back to this and see. They add this and add this. So what does it mean? The 8 represent the small tint and the 12 represent what? The large tint, right? So it means that they will ask you. So when they say find, then you work out already, right? Then the next step, they always ask you, oh, explain the meaning of the answer in your part C. So by analyzing the working, you will see that, oh, it's actually the total number of the small tint and the large tint. Can? So a lot of students always ask me, Jill, I don't know how to explain the meaning. How do I know what is what? So by just looking at the working, you'll be able to see what are they trying to ask you to find. You understand? So this is for question 5. Okay, a rice merchant packs his rice in a package of 2 kg, 5 kg, and 10 kg. So the rice got different size. He supplies the rice to 4 supermarkets. So supermarket A, B, C. So they put it in this table and they mentioned that the number of each package of rice supplied to each supermarket and the number of deliveries are shown in the following table. Okay, so it means that you have 12 delivery per month. Okay, 15 delivery, 10 delivery, and 20 delivery for each supermarket. And then they tell you that the cost of 2 kg, 5 kg, and 10 kg is $2.60, $7.20, and $14.50. Okay, paste this here. Okay, they say write down 2 metrics such that the elements in their matrix product represent the total number of each package or rice delivered to the supermarket in that month. Find the matrix product. So you see, first they ask to say the delivered to the market. So you know that you need to use the 12, 15, 10, and 20. Okay, and then after that, the next thing is you need to know that they want to use the different rice, right? So you know you need to put this. So the question is, this is a 1, 2, 3, 4 row, 3 column, which is a 4 by 3. Okay, and then if I put this in this way, it will be called a 4 by 1. Remember, just now I said that whether we want to put it in front or behind. So you see, 4 by 1, I cannot put it as in the 4 and 4, I cannot put it in the middle. So in this case, I will have to switch. You understand? That's why this have to change to become 1 by 4. Using the same number, but it has to be 1 by 4, which is 1 row and 4 column. And that's why they put it this way, and it must be in front. So it is 12, 15, 10, and 20. 1 row by 4. And then this, you can just put it as a per normal. Okay. And then it will be 1 by 4, 4 by 3. Then it is called a valid multiplication. You understand? That's why don't underestimate writing out the order. And of course, so-called the 4, 4 is already the same. So you will know that you will end up having a 1 by 3 matrix. So find a matrix production. Okay, I'm not going to do that. Then you will get a 1 by 3. You see, we get this number. This is a 1 row and 3 column, which you can say, oh, I'm definitely correct already because I got my order correct. Okay, next, write down the true matrix such that the elements in their matrix product represent the total amount of money paid for each delivery. Okay, by find this matrix product and hence write down the total earning of the merchant by supplying rice to market A, B, C, and D. So we know they're going to use this one over here, and they're talking about the price, right? And we know that this one is 4 by 3. Now we go to the next one already, part B, which is 4 by 3. We know that we're going to put something which is 4 by 3 here. And we know we want to talk about the price, right? We want to talk about the price. So the price we know is 260, 720, and 1450. But we know we can put it in the row form. We can also put it in the column form. So how do you decide, right? So we know that it is either same thing by 1 by 3, or it can be a 3 by 1. But because this first matrix is 4 by 3, the only common numbers I have is the 3. So it means I don't have other choice. I must put it in the form of 3 by 1. So this is out. So I know I have to use in 3 by 1. So 3 by 1 means it's 3 row, 1 column. Correct? So it means that this one, I will have to put it as 260, 720, and 1450. Because it is called 3 by 1. Then it will be a valid multiplication. You understand? So this will be the 2 matrix. And after the then you get the 4 numbers. So then after that, this is 4 numbers. Oops. This is the ending is 4 by 1. I was thinking why different. Okay, the ending is 4 by 1. This one was just my money. This is the money, which is like I'm deciding whether should I use 1 by 3 or 3 by 1. And the ending is a 4 by 1, which is 4 number because it represents the market, supermarket A, supermarket B, supermarket C, and supermarket D. Okay, then after that, they ask you for the total earning. Okay, they never ask you to use any metric, right? So actually what you need to do is you just add all 4 of them together and you get the total price of the supermarket. Can? So if you notice, actually, if you look back to your 10-year series metrics, the number of questions are almost always the same. And some of the 10-year series metrics question even shorter than this one. Okay. Okay, store A, B, C. So they put it in the table form for us already. They tell us the selling price is $1, $1, and $2 respectively. So they also tell me, okay, matrix M is this one, which is actually all this thing. And then matrix N is 112. So they also put for us already, which is the money, right? It is given that P is equal to MN, evaluate P. So of course, the multiplication, you know how to do it. But the tough part is describe what is the meaning by the elements of matrix P. So like I mentioned, we have to analyze the multiplication of the individual number, then we know what is the story like. So let's do it. P equals to MN. P equals to MN. So I'm going to just take 30, 42, 27, 24, 36, 8, 9, 8, and 12. N will be 112. So this is a 3 by 3. This side will be 3 by 1. So I know my ending will be a 3 by 1 number. Okay, so 3 by 1 number, let's see. First row, first column. So this and this. I'm not going to do the whole thing. I just want to see. You see, 30 times 1. I just want to show you 30 times 1 plus 24 times 1 plus 9 times 2. Then you will do this, repeat the same thing, and then after that you have 3 numbers, right? Then let's take a look. Okay, they take 30 times 1, which is they take 30 times 1 plus 24 times 1 plus 9 times 2. So they're actually finding what? They are finding the total earning for store A. You understand? So when it has 3 separate numbers, it means that it is the total earning for the 3 store. Because when I end up having 3 numbers, it can also means that it's a total amount for strawberry. It can also means that it's a total for mango. It also can mean that it's a total for durian. You understand? I have 2 ways. Either it's a total for store A, total for store B, total for store C, or strawberry, mango, and durian. So you don't know which one is the correct answer. That's why you always have to analyze the number and see, oh, they take 30 times 1, then they add to 24 times 1, then they add 9 times 2. They're actually adding the first row. So it means that it is referring to the store A, store B, and store C respectively. Okay? Next, given that K is equals to a 1/3, 1, 1, 1, 1, evaluate KP. So what does it mean? Okay? KP means they're going to use this, then after that multiply by KP. Multiply by the P. So this 1/3 means what? You have 3 stores. Okay, and your P is the separate for each store. It means that you are trying to find the average for the 3 stores. Okay, but you see, do you see that there's a, so it's like you're trying to find the average for the 3 stores in July, because they over here have a July. But even if you miss out the July, it's also okay. The main thing is you see that it is divided by 3 and there's 3 stores is because it is finding the average. Okay, so you just evaluate the normal multiplication by matrix, and this is how you explain the meaning. So that's for question 7. Okay, not doing this, not this question. I just want to talk about this thing because I forgot to include this question in this worksheet, but I want to highlight on this thing. So sometimes they say use matrix, okay, 10% discount to be on the first number. Okay, let's say this one is weekday, $380, let's say it's a weekday. Weekdays. And then the $420 is for the weekends. Okay, 10% discount for weekdays. And then let's say I have 15% discount for weekend. Then they say use matrix multiplication, okay, to show what is the final amount after discount. Common student will say, oh, okay, I know 10% discount after discount is 0.9. Then they will say, okay, I'm going to put 0.9. Okay, and then after I'm going to put, let's say 0.85. Okay, but let's see, this one is a 2 by 1. So I need to put a 2 by 1. 1 row, 2 columns. So I have to put 0.9 and 0.85. This is what common student will just put. But you see, when the question say, I want the final amount for 2 numbers. So if I'm going to do this, I will get a 1 by 1. Because it will take this one times this one plus this one times this one. And I will end up having the total amount and not the individual amount. So in such a situation, how do I do a matrix multiplication that I will end up still having 2 numbers? So the trick is, this have to be a 2 by 2. And how do you make these 2 numbers become 2 by 2? You will put 0.9 at the first one because I want to multiply 0.9 to 380 because it's meant for the weekday. This one, I don't want to include, so I'm going to put 0 here. This one, the 0.85 is to multiply to the second number. It's not multiply to the first number. So I put the 0.85 over here, and the first one I put 0. So you see how I'm going to work out? It will be 0.9 multiplied by 380, which makes sense because it's the weekday. And then I plus what? 0 times whatever, give me 0. So I just plus 0. Okay. Then I will go to the next row already, right? So it becomes 0 times 380. I plus 0.85 multiplied by 420. and I end up having one number and the second number. And do you notice the first number represent the weekday and the second number represent the weekend? You see, I never do my matrix multiplication by end up adding the two numbers. I still end up having two separate numbers. So the trick is to put it into this form by putting in the 0 inside. You understand? So this is the trick. This is the trick that you are supposed to use when they say use matrix multiplication to find out the final discounted rate, discounted amount. Can? Do you get this?